The climate change is going, and there are several events during the last decade happening that make quite severe impact on our life, like Fukushima event, like horrible algal blooming events, and many others. And this shows a great importance on how we communicate with each other to solve these problems, how we raise our economies. So that's why the United Nations declared the decade of ocean science for sustainable development in 2021 up to 2030. So this is very important, I think, for collaborations between our countries. So we are a global community and have to change our planet in a good way. So, and our session is devoted to these things. So in particular, we expected that our key contributors will show how they solve some problems in their regional scale, how they perform their research, how they perform their natural management, and so on. So before we proceed, let us to remind you that your speech is only for 7 minutes up to, and then after all meetings, we will make some short discussion, so you can ask questions to each other, or you can make some remarks about some presenters of their presentations. So then, when you start your speech, please mention your name, your position, your institution, and you have only 7 minutes for your talk. So Alexei, please present our first speaker, and let's go.
Thank you, Dr. Rubinikov. Dear guests, it's my greatest honor and pleasure to the session we have. Let us begin. And the first speaker of today's session is Dr. Natalia Stapran, Director of the Department of Multilateral Economic and Special Projects of the Ministry of Economic Development of the Russian Federation, Russian APEC Deputy Senior Official, with a statement titled Transition to Sustainable Ocean Governance. Dear colleague, please, the floor is yours.
Thank you, colleagues. Thank you, Kirill, for the opportunity to share with you the results of our findings. Our department within the Ministry of Economic Development explore different aspects of multilateral cooperation, and with special attention to SDG agenda and green development. So today I wish to take this opportunity to present to you the key findings of our analytical report. I guess the hosts do have the presentation, and if we have this opportunity, I will appreciate showing the slides, if it's possible. So the name of the report was The Blue Economy Concept and the Overview of International Sustainable Governance Practices. And I guess, is there the presentation?
Zoom.
Okay, yes. Yeah, thank you. I hope everyone can see it. It is the result of our study of multilateral.
No, we could not see the screen. Sorry.
Okay.
It's not shared.
Could we ask to share the screen, or I can do it myself if it's possible? How should we do it?
Colleagues, I think that it's shared at the venue. So here to all participants, to let all participants to see it, maybe Professor Dr. Stapran, you can share your presentation too. And I think the issue will be solved.
Okay, I guess this way. Colleagues, is that better?
Yeah,
Yeah,
it
now
works.
it's great.
Okay, I'd like to show the screen, just a second to make it bigger. Okay. Anyway, I guess anyway it's better than nothing. Okay. Sorry for this inconvenience. I'm just trying to tackle all the issues. So, sorry. Yes. Sorry. I guess yes. This way. That's better. Yeah. So the world ocean provides humanity with huge opportunities and resources for development. And I would like to provide you with some figures which we find out. For example, WWF estimates the global value of the oceans at the $24 trillion, and 3 billion people sustain their lives due to the ocean resources. So 30% of CO2 emissions are absorbed by oceans. And recently, as Cyril almost said already, almost all world's oceans has been damaged by human impact through overfishing, unstable ship fishing, mining, and pollution. So let's look at these alarming figures. So 57% of fisheries reserves of the world's ocean are completely exhausted, and 30% are being depleted. So 5 to 12 million tons of plastic annual are dumped in ocean, and 11 to 26 million tons of annual illegal fishing is being undertaken. Around 2.1 billion annual direct damage from plastic waste to the ocean only in Asia-Pacific region. The degradation of world's ocean ecosystems and the depletion of its resource base inevitably affect the well-being and health of people who live in the countries that depend on the oceans and seas, and it also brings huge financial losses. Is therefore hardly surprising that interest to the blue economy a concept is steadily growing. Today it is on the agenda of many international organizations, and the concept embedded into the number of national development strategies. The specificity of the blue economy concept is the emphasis on the system and sustainable development of the economic sectors related to the use of oceans and seas. And that is what's really important for especially my Ministry of Economic Development. The blue economy concept supposes the transition from the traditional sectorial management approach to the ecosystem one. And it offers such policy tools as integrated coastal zone management, marine spatial planning, and the creation of protected marine territories. However, in spite of the rising popularity of the concept, it is difficult to make international comparisons of the level of the blue economy development, as there is no terminology and sectorial unity in understanding what blue economy is. And I will really appreciate if my colleagues, my foreign speakers in today's session probably will tackle this issue also and share with us what is being done in your country. Our analysis of national strategies of the development of the blue economy in European Union, India, Indonesia, Canada, China, and some other countries showed that difference in approaches in terms of the blue taxonomy, coordination mechanism, statistics and measurement, but unity in goal setting and description of key policy approaches. This provides the ground for multilateral cooperation in order to the formation of an international legal framework and the development of unified indicators. Here, I guess probably not, yes, on this slide, you can see just some of the main international agreements in this area. I won't list all of them, but I would say that one of good practical tool developed in recent years is the UNCTAD principles and criteria for bio-trade, for example. It is estimated, now I would like to say just several words about the economic opportunities of the ocean. It is estimated that the added value of the industries related to the sea and ocean will more than double by 2030. And those industries include traditional sectors such as marine tourism, port activities, fishing, and fish processing, but also include emerging or new sectors. Emerging blue economy sectors include, for example, renewable ocean energy, tidal energy, wave energy, marine solar energy, offshore wind energy. The ocean floor contains the minerals that humanity needs for the green transition. Marine biotechnology allows the development of new pharmaceuticals, medicine, cosmetics, feed additives for animal husbandry, which reduce methane emissions into the atmosphere. I hope that also some of these aspects will be discussed today. In our own report, we examined the number of international projects in emerging sectors of the blue economy. I just listed several of them here in the slide. For example, the world's largest tidal energy plant in South Korea, the United States project of open ocean wave energy system, Parkway South in Oregon, and Singapore offshore floating solar farm in the Straits of Johor. Offshore wind farm Hornsea in Great Britain, and many other examples can be found worldwide. Our studies showed that economic potential of those emerging sectors of the blue economy has been revealed very little today. The introduction of these innovative technologies should be completed by sustainable management, and that is really important. And finally, I just want to share with you, as the representative of Russian government, what are the ideas within our regulation of the ocean. The ecosystem approach is also the heart, I would say, of Russia's national policy. And according to our national approach, our marine activities should meet the principles of sustainable development and security. And our key regional policy areas and geographical areas such as Arctic, Atlantic, Pacific, Caspian, Indian Ocean, and even Antarctic region. In accordance with international rules and trends, our policy provides first implementation of comprehensive approach to planning of seaside and coastal areas development, people-centric priority for whom fishing is a basis of existence, and ensuring conservation priority of Arctic bioresources and its sustainable use, system development of state environmental monitoring, ensuring security of maritime infrastructure and their adjacent areas. Modern challenges to the development of the blue economy create the need for the formation of international approaches to their settlement. So our study showed that the following trends: the creation of new formats of international cooperation and new mechanisms for financing the blue economy projects, the formation of an international legal framework for development of ocean resources, and the development of indicators to measure the blue economy. And for all those purposes, we really need well-educated researchers. So I really thank Far Eastern Federal University organizers of this session, because we hope that the new people who will do all what was listed in my presentation are being born there in Vladivostok. I really hope that today's discussion will help us to go further and develop this agenda. Thank you for your attention.
Thank you very much for your presentation and statement. And now we're moving to the next speaker, that we have for today's session. That is why I'm glad to invite Dr. Fangli Cao, Chair Professor and Deputy Director General, First Institute of Oceanography, Ministry of National Resources of China, Director at the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific and Cultural Organization, Regional Training and Research Center on Ocean Dynamics and Climate. Dr. Cao is the editorial board member of Journal of Marine Systems, Ocean Modeling, and Acta Oceanographica Sinica. Due to his excellence in research, he has received many academic awards, including the Worcester Awards of North Pacific Marine Science Organization and Outstanding Science of IOC Subcommission for the Western Pacific in 2014, the New Century Talents National Candidate in 2007, and the 9th China Youth Science and Technology Prize in 2006. Dr. Fangli Cao, the floor is yours. You're welcome.
Thank you, Chair. It's my great pleasure to have this opportunity to share some ideas with all of you. So as executive planning group member of the UN Decade of Ocean Science for Sustainable Development, so my topic is a capacity development of UNESCO IOC, Regional Training and Research Center of Ocean Dynamics and Climate. So as we know, there are 7 outcomes for the UN Ocean Decade. So it's a clean ocean, predicted ocean, health ocean, safe ocean, productive ocean, accessible ocean, and exploring and engaging ocean. So today, my talk will focus on predicted ocean. Here, the predicted ocean not constrained to ocean itself, but also including the climate. So before we talk about the predicted ocean, we need to analyze the challenge. The ground challenge for the ocean simulation and prediction is the mixed layer. The mixed layer, as we know, the left I show is for the observation. As the mixed layer is so important for the climate, for the marine ecosystem. However, we could not simulate properly this mixed layer depth in the global ocean. As we know, the right is from a simulation result. The color bar is the same. As we know, in the higher latitude, from the observation, the mixed layer depth is about 100 meters, but from a simulation, it's only 10 meters or so. So this is a challenge faced by all ocean circulation models. So what we do is we developed the surface wave-induced mixing theory. We discovered the key role of surface wave in the vertical mixing. As we know, before in the ocean circulation models, we never considered the surface wave because the surface wave, the scale is too small. It's only several seconds in time scale and only 100 meters in space. However, for the ocean circulation, when we talk about the ocean circulation, it will be several years, even to centuries. Okay, so by including this process, we can compare the bottom. The bottom is from observation, the mixed layer depth. The middle is for the traditional models. So we can lot of difference. And the upper panel is by including the surface wave. So we can clearly see how important of the surface wave in the ocean circulation system. However, this process is never considered previously. So based on this understanding, we developed the first in the world, the surface wave tide circulation fully coupled model. And this model we compared with different models from different countries, like the form from UK, from France, from United States, from Canada. So our model performance is much better than the present, the leading, the result from the leading agency of these countries. And this result is also applied in the search and rescue. Here is a real example. In July of 2018, the two boat is have accident off the Phuket Island, and we use this ocean forecast system to predict where the people will be lost, and the result totally confirm our forecasting result is quite good. So the next is for the climate. As we know, climate is so important. However, the prediction of the simulation prediction of the climate system, we have so huge, bias. This is a multimodal mean. Multimodal mean means if some models maybe overestimated, some model maybe underestimated, take an average will be much better. Even this in these conditions, the bias can be more than 4 degrees. As we know, the ANSO play a very important role. The ANSO is only 1 degree or a little more than 1 degree anomalies. That will cause, the response of the global ocean and the global climate. However, the climate model faces so huge bias. So this is the problem. And by consider this the surface wave process, we can much improve our simulation ability. In average, the bias can be reduced more than half. So as we know, for climate system, this is a huge improvement. And we also share this new result through training. In our institute, we host the first regional training and research center of UNESCO IOC. So this center is called ODC. It's focus on ocean dynamics and climate. And this center focuses on 4 correlated areas: ocean dynamics, ice interaction, numerical modeling, and climate change. So this is during the past 10 years, this is our training activity. So I believe this is a strong support for the contribution to the global ocean. And as we know, this from during the past 10 years, we received more than 1,000 applications from 66 countries, and we have more than 500 trainees from more than 50 countries to take part in this training course. And for this training course, we have not have only training and learning, and we also include the practice and discussion. And finally, we have application and cooperation. So we call that it's TPA, is training, practice, and application. So I make a summary because the time is quite limited, only limited within 7 minutes. I don't want to take too much time. So my summaries have these 3 points. The first is with the scientific breakthrough on ocean turbulence, we have dramatically improved the forecasting ability of ocean and climate. The second is contribution on capacity development in the past 10 years. And the last one is we will continue our efforts to the world on predict the ocean and the UN Ocean Decade. Thank you so much.
Is the another representative of China, Dr. Zhou Zhenzi, Associate Researcher, Institute of Atmospheric Sciences at Fudan University. Dr. Zhenzi obtained a PhD in physical oceanography in Ocean University of China. The sphere of scientific interests of the professor covers such areas as ocean atmosphere interaction and global climate change, southern oceanography, and its teleconnection. Professor will represent his speech titled Ocean and Climate Extreme Events, past, and future. The floor is yours. Please, you can start.
Thank you, Chair. Good afternoon, everyone. My name is Zhen Qiangzhou from Fudan University in Shanghai, China. It's my pleasure to attend the APEC conference on cooperation in higher education. Today, I would like to introduce you the ocean and the climate extreme events and their socio-economic influence. This figure, this figure shows the global mean temperature anomalies during the past 140 years. As we can see, a robust global warming of about 1 degree since the last century, and the scientists are this is due to the increase of the anthropogenic greenhouse gas increase. And in addition, as we can see here, the past 6 years are hottest on record, and the increase of mean climate are associated with the increase of extreme events. As we can see here, the record set heat dominated the North America and Europe and the East Asian regions. And in May 2021, and a record heat wave hit the Arctic region. As we can see here, 32 degrees in Russia, which is a new record since 1897. And 2 months later, another record heat wave hit the Pacific Northwest region, and this caused the deaths in 107 deaths in the US and almost 500 deaths in Canada in only 5 days. And the scientists package the heat wave as a 1 in 1,000 year event in today's climate. And analysis suggests that after 20 years later, a heat wave of this magnitude could be expected roughly every 5 to 10 years. So let's move to the Asia Pacific region. This is a very famous photo, as many of you may have seen it before. As the droughts and bushfires in Eastern Australia last about 1 year, from June 2019 to early 2020, and caused significant economic and environmental damage, such as it burned 18 million acres. And on the other side of the Indian Ocean, a wet condition in Eastern Africa triggered a locust outbreak, as it provides a favorable humid condition for locusts to breed. And this photo shows the swarms of desert locusts fly above trees in a village in Kenya in January 2020. And then 2 seasons later, in summer 2020, a devastating Yangtze River flooding occurred in China, and this flood water reached the toes of the Leshan giant Buddha statue in the Yangtze River basin for the first time since the establishment of China in 1949. And it is the largest and tallest stone statue in the world, with about 71 meters tall. And this historical Yangtze flood killed 141 people and caused an estimate of about 11 billion in damage, and displaced millions of people at the peak of COVID-19, creating the potential for a public health crisis. And one of the major reasons that these extreme events cause such huge losses is that they were not supposed to happen, aka we are failed to predict them. And today's mainstream forecasting has traditionally considered what is happening in the Pacific Ocean foremost among the factors to consider in deciding if winter seasons will be El Niños or La Niñas or somewhere in between. However, the 2019 and 20 El Niño is very weak, as we can see here. And then these extreme events are not able to be predicted. Now people know that the Indian Ocean dipole event in 2019, which is the record strongest in about 150 years history, with enormous cold in the Eastern Indian Ocean and warm in the West Indian Ocean, triggered a bushfire in Australia and heavy rainfall in the Eastern Africa. However, its capability to trigger the heavy rainfall in East Asia after 2 seasons later was little known. Our recent work here, find the physical connections between them. This is a schematic, which is too complicated that I don't have enough time to introduce. But the results of our study surprised us, as the Indian Ocean, which is much smaller than the Pacific, can generate variability largely on its own and help predict the devastating climate events over rim countries. And this is the ocean raspberry wave, which moved westward slowly from 2019 summer to early 2020, which brings the predictability. And based on our results, climate dynamic models can successfully predict the Yangtze flooding at least 1 to 3 months earlier. And this makes an important occasion in that climate models outperform the empirical predictions that the operational agencies still rely on. These are the same computer models that scientists use to project future climate change in the face of increasing greenhouse gases in the atmosphere. So for the future, as we know, weather prediction only work well within 2 weeks with the atmospheric internal processes. If we want to predict the climate longer than 2 weeks, we must couple the atmosphere with the ocean conditions, as showed by Professor Chiao. So if we want to predict the regional climate extremes and its changes and the associated economic influence and anthropogenic warming, we have to study the climate variability and probe the physical processes. So, okay, that's all. Thank you.
Have that experienced and motivated speakers on the floor, the true experts in the areas of the presentation. Still, as we are running out of time a little bit due to the schedule, we would, both of us, with Dr. Vinnikov, would kindly ask you to follow the time limits we have for the presentation. Thank you for your attention. And now we move on to the next presentation by Dr. Satoshi Ishikawa, Professor, School of Marine Science and Technology, Sakai University. Dr. Ishikawa has conducted interdisciplinary study for harmonization between rural development and conservation of ecosystems in coastal area of Japan, Thailand, Philippines, and Cambodia. Has many academic achievements in phylogeography, fisheries science, and area study. Dr. Ishikawa will deliver a speech titled Coastal Area Conservation for Sustainable Fishery Using fishery using molluscan slag and artificial seaweeds. Please welcome.
Thank you, Chair. My name is Satoshi Ishikawa, working for Tokai University, Japan. Today is a very honor to me to share my ideas and some results of my research. So I prepared some videos to my presentation using the PowerPoint files. So let's start for my presentation using these files. I would like to show some example of my research for conservation of coastal ecosystems for sustainable fishery. Growing world population exists on the background of my research. It will exceed 9 billion by 2050. Under this situation, food production and supply will be serious issues of the world. According to the forecast by FAO, United Nations, to feed the growing world population, at least 60% increase in food productivity is required by 2050. And it is said that we will face a serious protein shortage in near futures. because in current food systems, a lot of grains are used for protein productions. Even if the grain is not enough of the world, against global food shortage, expectations and demands for fishery products has been larger recently. For sustainable fisheries, conservation of coastal ecosystem is indispensable because high productivity and high biodiversity areas are limited in the coastal zone, and coastal zone has a lot of spawning and nursery habitats for many species. However, unfortunately, this importance of coastal ecosystem is sometimes ignored and forgotten in the modern economic systems. For example, in Japan, during the rapid economic growth period, 90% of tidal floods in Tokyo Bay and 40% of seagrass beds in Seto Inland Sea were vanished by reclaimed. Subsequently, fishery catch in both areas had been drastically decreased. Moreover, marine debris threatens a lot of marine life recently. Most of marine debris that can be a source of microplastics comes from human activity on land. So good waste control and management in the land is necessary for coastal conservation and our food safety. Here, I would like to show a good example of good waste management using the incinerator with high temperature, more than 1,700 degrees. Nippon Steel Engineering can provide this kind of incinerators. It makes garbage into a good quality of molten slugs, which can be used as agricultural fertilizers. So far, the molten slug has been very successful in vegetable cultivations. Now we are testing the potential of this molten slug as a material for the artificial beach constructions and coastal conservations. Last year, we confirmed at least 19 basic species inhabiting at the artificial beach. The number of species and amount of biomass of them are not different from those of near natural habitats. So we think molten slug can be used for beach nourishment and conserve the tidal flood ecosystems. We are now considering to use artificial seaweed instead of the reduced seaweed and seagrass bed in coastal areas. The artificial seaweed is made by polyethylene, so it is very light and easy to handle. So far, 5 years tolerance against strong waves are confirmed. We use these materials. We can make seaweed bed and seagrass bed at any areas where in no natural seaweed. This artificial seaweed can be nest for many marine species, and it can be a landing base for natural seaweed too. Now we are testing its durability and impact on surrounding environment, including measuring the material flow between land and oceans. The coastal ecosystems, which was once destroyed by human activities, cannot be restored by nature. To conserve and to restore the coastal environment and ecosystems, we have to do something to care of them. Beautiful beaches and high biodiversity have much economic values in not only fisheries, but also in other sectors, including tourism and education. This is my message. Thank you very much for your attention. So thank you very much.
Thank you very much for the presentation. And now we'll move to the next speaker, which is Professor Wei Tafan, Director, Graduate Institute of Environment Education at NTNU. Professor Wei Tafan is currently serving as Distinguished Professor and as Director of the Graduate Institute of Environmental Education at NTNU, and is President of the Society of Wetlands Scientists, SWS Asia Chapter. He was awarded the designation of Visiting Research Fellow at the Northeast Institute of Geography and Agroecology, CAS. And now Professor Wei Tafan will present on the topic Ocean Science and Education Towards Sustainable Development Goals. So, Professor, the floor is yours. Please proceed.
Thank you very much. And I will just use my movie clip.
Ocean science
Please show up.
education toward Sustainable Development Goals, SDG. We know the UN Decade of Ocean is our time to contribute Asia-Pacific contribution. So this is real, and this is a lot of opportunities we can contribute. I'm a distinguished professor and director, Graduate Institute of Environmental Education, President of the Society of Wetland Scientists Asia Chapter, and observer.
Excuse me, could you share your screen?
I just share some experience to you about the human ecology and anthropogenic influence on Mother Earth. Right now, we are at the period of Anthropocene. So we need to have some environmental planning from our scientific rigor. Just focus on ocean literacy. So it is important to design your outreach studies beyond social distance pressure on our studies. I get 3 degrees from Arizona State University, Harvard University, Texas A&M University in the United States, 2 masters and 1 PhD. So this is our dynamic process to do advanced studies forever. Most of the time, my students just argue, I love sun, beach, and the sea, but I hate animation. I hate mosquito too. This is my series from the Explorations Toward Wellness. Most of the students, since their childhood, they love to watch video games. So a lot of students, maybe they don't have a lot of experience of the ocean. In Asia, most of people, they don't like to see ocean because ocean may be very dangerous. So another series, that is, we just focus on the attachment affiliations you back home, because your father and the mother take care of you. But how about the distance learning? I think sometimes it's quite safe, but sometimes boring, maybe. The message from the Society of Wetland Scientists tell us, if we have ecosystems, we should keep a stable structures without unstable structures. That is the function of resilience. This system was recovered due to resilience to restore its carrying capacity. So how about the ocean literacy? we call transformation to sustainability. If you have a bold circle with the environmental arts and the environmental education, you should focus on some science and your personal feelings. Sometimes you need to transformation of consciousness, maybe under consciousness, but you need to change your attitude toward your environmental friendly behavior. So go diving. Go diving, that is not just fun, but we must learn a lot of theory from your knowledge, attitude toward per environmental behavior. So social support and self-sufficiency is very important. One guide tourism in emerging economies, it is very interesting to do many social studies and the social work we call environmental education. The environmental education focus on childhood toward to adults. A lot of fun should be based on responsibility. We need to reduce impact and toward green and ethic tourism. I did a lot of survey in the coral reef areas. So this is the responsibility. What is the relationship between ocean literacy in SDGs? This is a time to create my model from different SDGs. Since we have a partnership for oceans, we need to educate people to go diving with responsibility. So if this forward control is positive, a lot of people follow me to restore life below water toward clean water. But if our feedback control is negative, a lot of coral reef die. So rethinking your diving consumer behavior. Sometimes coral reef ecosystem is fragile. So how about the recovery for the resilience? I create a model to see some branch coral and the multicolor stone recovery. But if you can see the endangered species, so a lot of local extinction from the reef gone, because this is a situation of unstable structure. I wrote a book, Envisioning Environmental Literacy, during 2020. I have to explain many literacy from the knowledge, attitude, and the behavior. So welcome to submit your journal paper, because I'm the editor for the press, for the wetlands, for the sustainability. My book focuses on many perspectives, like scuba diving, snorkeling, and including tribe knowledge. What is the tribe knowledge? This is including traditional ecological knowledge. That is our Asian Pacific perspective thinking, because culture, biodiversity. I have a dialogue with hunters. Sometimes they toward to protect environment, because they have ecosystem knowledge of the planting fish. It's looking like a rotation in different tributary in the mountainous areas. And we also have the plateau systems in Asia. talking about the hunting knowledge. The indigenous people release small fish and catch big. A lot of subsidiarity thinking inside. So what is our balanced ecosystems? Keep these ecosystems stable. So I just says, may the force be with you from different elements in its philosophy. East Asia, we have many good seascape, landscape. We enjoy to looking at the mangrove, and we have many beautiful landscape, if you like, toward to sustainable management. My work is just a focus on different focal points. But we love to traveling, but right now it's COVID-19. We can't. How can we do to increase everybody's pro-environmental behaviors? So we're teaching at universities, but maybe we have a quarantine at home right now. A lot of students love to play computer games, but how can we do if online learning doesn't work? Be relaxing because I have 2 kids. I accomplished with them for almost 100 days. We can create EE results from our book. We need to think about reality. We need to think about ecotourism by cycling and snorkeling for kids. So this is my talk. Touching demands is our Anthropocene's work. We need to get a pure connection. That is a good message from me. This is a way to have fun. I'm looking forward to seeing you soon. Thank you very much. Good morning, ladies and gentlemen. My name is Wei-Ta Feng. Today I will show you ocean science and education toward sustainable.
Thank you very much.
Presentation. And now we move into the next speaker in the list we have for today's session.
I'm a distinguished professor,
which is
over environmental education.
Well, sometimes it's working, not connecting with the way we're trying to organize it. So the next speaker in the speakers list is much respected Professor Marie Kobayashi, the faculty of Bio-Industry member, Department of Ocean and Fishery Sciences, Tokyo University of Agriculture. Professor Marie Kobayashi has been worked in the Department of Aqua Bioscience and Industry of Tokyo University of Agriculture since 2006 as a lecturer, associate professor, and professor. She published 20 science papers and the book The Wild Mammals of Japan. Professor Marie Kobayashi will present topic titled Seal Management on Understanding the Role of the Seals in Marine Ecosystem. Dear Professor, the floor is yours. Please proceed.
My name is Marie Kobayashi from Tokyo University of Agriculture. Thank you for giving me the opportunity to make a speech today. The harbor seal and spotted seal inhabit Hokkaido, Japan. For many years, I have been studying long-term population change and change in distribution associated with environmental change in these species. Based on these results, I will give a speech entitled seals management on understanding the role of seals in marine ecosystem. I hope that today's speech will suggest how to resolve the conflict between wild animals and humans in the future. First, I will explain the background or why seals management is necessary. The basic industry of Hokkaido is fishery. In recent years, due to decline of fishery resource and soaring food prices, the pelagic fishery used to be mainstream, but it has changed to a standby fishery along the coast. On the other hand, the southern limit of seals distribution in Hokkaido, the number of the seals increasing due to the drastic decrease in the use of seals by humans. In addition, the area of visiting expanded due to the decrease in drift ice due to climate change. Since seals are a generalist on the coast that prey on any predatory fish, placed with high fish collecting properties such as a standby fishing net become feeding ground because they can easily forage. Therefore, the fishing ground and seals habitat overlap, and the annual amount of damage to the fishing industry is more than 400 million yen. Therefore, seals are positioned as a harmful animal in the sea. It is indispensable to adjust the population of seals in order to reduce the damage to the fishing industry. However, the relationship between fishery damage and seal alone does not actually solve the problem. Therefore, I thought that not only seals should be regarded as a harmful animal, but also the role of seals in the ecosystem. Their feces and urine are scattered in the sea, and seals' carcass have a high proportion of biomass in coastal. From this, it was thought that a large amount of amino nitrogen become inorganic nitrogen via bacteria and was great involved in the growth of kelp. On the other hand, although kelp in Hokkaido is the most important fishery target species, shore burning in which large seaweed such as kelp disappear has been a serious problem. The place where kelp is overgrowing is also breeding ground for fly and the origin of the marine ecosystem. In short, seals may be helped to revitalize marine ecosystems. Therefore, in this study, we aim to see if harbor seal contribute to the overgrowth of the kelp in Erimo of Hokkaido. As for marine organic nitrogen, ON is decomposed by bacteria and dissolved in organic nitrogen, DIN change from NH4, NO3, NO2, and NO3. The total nitrogen, TN, is known to fluctuate seasonally like this. If there is a lot of NH4, it derived from animals. And if a lot of NO3, nitrogen is supplied from the seabed. Also, by knowing the existence of seal-derived environmental DNA in seawater, the nitrogen there may be derived from shale. Furthermore, by measuring the stable isotope delta 15N of kelp, it is possible to estimate whether kelp is assimilating nitrogen of a high predator. Using these three methods, we investigate what kind of influence the harbor seal have on the kelp in the sea, in the area. The survey site was the Erimo, located in the south part of Hokkaido. Harbor seal uses the same land site for the whole years. In Erimo, the landing site is on the reef zone at the tip of the Cape Erimo, where about 1,000 seals live. Sampling collected seawater and kelp like this slide. First, let's divide the seasonal change of the amount of DIN into the Erimo area and the reef zone. The amount of DIN in Erimo area decreasing from spring, depleted in summer, and increasing from autumn. In the reef zone, it was found that the amount of DIN is high, especially the amount of NH4. In other words, it was suggested that animal-derived nitrogen is supplied to the year-round in reef zone. Next, in the result of environmental DNA derived from seal in seawater, eDNA was measured at 4 locations from Erimo area and the reef zone. As a result, eDNA derived from seals was detected almost only in the reef zone. In other words, the high eDNA of seal in reef zone suggested that there is a high amount of seal-derived nitrogen. Finally, it is a result of a stable isotope delta 15N and the difference in wide length and wet weight of kelp from June to August.
I apologize to interrupt, but we out of time. So could I please ask you to summarize the key topic of your presentation, because we really run out of time. Thank you for your understanding.
Okay. These results indicated that the harbor seal are an important source of DIN absorbed by kelp. In other words, the harbor seal as a top predator of the food web has been shown to play an important role of bottom-up control of ecosystems. We hope that the research will provide an opportunity to shift wild management from single species to ecosystem management in the future. Thank you for your attention.
Thank you very much for your presentation. I believe maybe the topic connected with seals is a very cute thing, and it was nice to connect that part of the wildlife and our academic topic for today, and that serious things connected with the decades of ocean science. And now we will proceed with the next speaker in the speaker list, which is Professor Kwon-Min Liu, the PhD, Director, Institute of Marine Affairs and Resource Management at NTOU. Professor Kwon-Min Liu holds a degree of Doctor in Natural Resources. His primary areas of expertise are pollutants dynamics, biological statistics, fisheries biology, and marine resource management. Professor Kwon Min Liu, please, the floor is yours.
Can you hear me? Wait, can you hear me?
Yes, we can hear you.
Okay.
Yeah, no
Okay. Thank you for the introduction. I would start my presentation. Thank you for the invitation to make a presentation here. So today my topic is mitigation human activities impact on the sustainability of fisheries, what university can do. So I would like to share some experience from my university. Before we are talking about the human impact on the fisheries, we like to explain actually fish population variation due to many factors from biological factors, environmental factors, and also human factors. Even in the human factors, the fishery is only part of them. Okay, so as you know, Chinese Taipei is one of the largest farsi fisheries in the world. So this one is the fishing effort of large-scale long-life fisheries in the world, and this is small-scale long-line. We have porcine fisheries in the Pacific. This one, and also we have squid fisheries, and we have sorry fisheries. So how NTOU involved in the APEC ocean and fishery working group issues. So we have 7 colleges in our university. They all dedicate to ocean focused education and research. So we have lots of the research. We have aquaculture, we have ocean pollution, we have lots of the research related to the marine issues. So, and also in addition, we have 2 centers of excellency. So today, our colleague talking about the climate change and offshore wind, farming, offshore windmill. So all related to these 2 centers. So in the past 12 years, our university involved with the APEC roundtable meeting on the involvement of business and private sector in the sustainability of marine environment. Okay, so these annual meeting hosted in Chinese Taipei every year. So for the past 20 years. So this is a platform to provide a platform for the private sector and public sectors to discuss and cooperation on the marine related issues. So there are 16 APEC economies have attended these meetings. The last one is in 2019, but unfortunately these 2 years because of COVID, we didn't have this meeting. Okay, our university organized the recent 12 meetings. So in the past 20 years, we have 3 major themes. Is marine conservation, like 50%. We are talking about MPA and some other issues. In marine pollution prevention is about 21%. It's like clean waters, marine debris, and also the fishery management like climate change, IUU fishing. And in addition to the meeting, we also published the 2 issues per year, the Bulletin on Marine Resource Conservation and Fisheries. And these are the pictures for the group photos for the past meetings. And this is also some pictures. After 2 days meeting, we also have a scientific tour to visit like museum and fisheries market and etc. Okay, and in addition to the APEC issues, our university faculty also involved in tuna, billfish, and bycatch, such as shark, seabird, sea turtle researches in regional fisheries management organizations. RFMOs in the Pacific Ocean, we have like ISC, International Scientific Committee, we have WCPFC, we have the new one, the South Pacific Region Fishery Management Organization, and also in the MPFC and IATTC. So ISC is involved, is focused on the albacore, Pacific bluefin tuna, billfish, and sharks. So we, our faculties, including me, joined this IS Shark Working Group starting from 2011. And the recent stock assessment of the blue sharks is in Japan, 2019. And also in the WCPFC is a legal binding framework work for the fishing entities in this commission. Okay, so we also joined the recent meeting in July, talking about the blue shark data preparation in the South Pacific Ocean. So in addition to this sharks research, we also some of our colleagues also involved other bycatch issues like seabird, sea turtle, using circle hood to see if they can reduce the sea turtle. Sea turtle is most in the tropical and subtropical areas, but seabird is mostly in the high latitude. And also we are hosting some joint tuna bycatch working group and observer meetings in 2015. And one of my colleagues also joined the South Pacific Regional Fishery Management Organization. They are focusing on the jack mackerel and jumbo flying fish and deep species. So these are the meeting pictures. The recent meeting is in New Zealand in 2020, and also the recent one is in August. Okay. So also the MPFC, they are talking about the Pacific, chopped mackerel, flying squid, and bottomfish. Okay. So these are the recent meeting. So one of my colleagues also joined this meeting. So our action in response to RFMO's management measures, if they violate the fishing vessel will increase the violation fine, we would release the plan of action of IUU and seabird, etc. So these are the responsibility for RFMO. For the last one is combating IUU fishing. So IUU fishing is a very hot topic in APEC topic. So I will talk about the combat IUU fishing. So in combat IUU fishing, we have this fishing vessel and catch monitoring system. So fishing vessel monitoring created based on VMS vessel monitoring system and AIS. Okay.
Running out
okay,
of time,
that's
so
the last one. Okay. So also one of my colleagues also developed the AI system with this, so we can get a better monitoring of the fishing activity. So finally is the recommendation. So because the time limit, I will stop here. Thank you.
Thank you very much for your presentation, your understanding. And now we are going to move to the next speaker on the speakers list. And I would firstly ask whether Professor Elspeth Probing successfully connected to the meeting.
Yes, can you hear me?
Thank you very much. So we're now moving to your presentation. So Professor Elspeth Probing the University of Sydney. Professor Probing is the author of several groundbreaking monographs and over 100 articles and chapters across the field of gender, media, and cultural studies, philosophy, cultural geography, anthropology, and critical philosophy. Her current research analysis the sustainability of the production and consumption of fish, results of which are published in the new book, As in the Ocean. Professor Probing will present on the topic, the future of oceans, what we know and what we don't know. Please, the floor is yours.
Thank you. Excuse me. Thank you so much. I'm trying to get my screen sharing to happen, but it isn't working, and I don't want to take up any more time. So I'll just go through the screens. My thanks to the organizers. Good afternoon. Dobry den, I hope that's right. I'm speaking to you from the Aboriginal country of the Gadigal people, where the University of Sydney is located. Now, I'm just going to take you through some things that we know and some things we don't know. So oceans, as many will know, allow us to breathe. 50% of oxygen comes from oceans. They allow us to trade. 90% of all cargo is transported by ocean. They allow us to eat. 3.1 billion people rely on fish for 20% of their daily protein intake. And of course, in some coastal communities, especially in the Asian Pacific region, they may be reliant on fish for up to 70% of their food security. What's less well known, and my colleague who preceded me touched on illegal, unregulated and unreported fishing, which I will go into. Distant water fishing, 5 nations dominate this, and they are especially fishing in the global south. Labor, the seafarers, fishers, etc., often is unregulated, indentured, and insecure and unsafe. And gender divisions in labor, although we often think of the fisherman as the quintessential male or masculine figure, 85% of processing, fish processing, is done by women, especially in the global south. Now, I want to turn to the question of UNCLOS, the United Nations Convention of the Law of the Sea, that was finally ratified in 1982. And it is actually through one of the articles in UNCLOS that allows for flags of convenience. The UNCLOS gave all states the capacity to fly their flags at sea, even if they were not sea nations. And when we're talking about flags of convenience, it's where there's very little connection between the flag state and the ship. And this is beginning to be overwhelmingly the case. This leaves seafarers without national and international protection, under poor labor conditions. During COVID, we've seen ships that have been totally abandoned. The seafarers are just left there to die, actually. Coastal nations in the global south equally were affected by an article in the Law of the Sea, which encouraged coastal nations not to waste resources. This has played out in licenses that are very poorly paid to the global south so that the global north can fish as much as they want. Then we have the rise of piracy, especially in Africa. And this also is a complex tale because as one fisher turned protector of the sea, e.g. a pirate, said to a colleague, "Why would anyone go back to fishing when you can catch an oil tanker?" And quite often that's because there is very little fish left in the ocean. Unfortunately, you can't see these graphs I have, but more than 8 in 10 of the world's families in the Asian Pacific region are reliant on fishing to live. And again, another slide you can't see, gender disaggregated data is rare, which is to say that data that's collected by APEC and by other large organizations does not differentiate between women and male workers. When we don't account for gender, when we don't count gender differences, we can't account for them. And this is incredibly important in terms of aid programs, development programs in the global south. Now, with wild capture overfishing, the turn to aquaculture is ginormous. 44% of the total production of fish is from aquaculture. The cons, fish are fed to fish. And again, a beautiful slide you can't see, 25% of non-food, 25% of global catch goes to non-food consumption directly for humans. This is to say that small fish such as anchovy, herring, krill, etc. are reduced in factories to fish oil and fish meal, which then goes to feed aquaculture, poultry, cattle, fertilizer. It goes into the omega pills that the wealthy nations tend to take. In terms of the pros, there is great technological strides being made. China in particular is absolutely ahead on this in terms of what's called integrated multi-trophic aquaculture systems. Now, this sort of is an extraordinarily scaled up version of the very ancient practice in Asian countries, whereby you have a fish on, you'd have a duck on top of the rice paddy and the carp below, and the carp would eat the feces from the duck. Well, now it's much more complicated, whereby you have fish meal that is fed in pens to the salmon or other carnivorous fish. This then falls their feces and leftover fish meal to organic, to filter feeders such as mussels and oysters, and then it falls to the ground where detrivores pick it up. This would be sea cucumber or indeed lobster, and it allows for the growth of seafood. Now, for APEC and for many, but I'm quoting from Patrick Moran, the lead, the lead shepherd for APEC's Oceans and Fisheries Group. The greatest, somebody mute? Right.
这是俄罗斯的一个大学办的研讨会啊 ，APEC 的研讨会，大学什么什么。
Great. The greatest enemies of IUU are the lack of communication and collaboration. But in fact, the greatest threat to our oceans is ignorance. And this requires better marine research and more collaboration. This entails the social sciences, humanities, natural marine sciences working together across and within regions and countries. And this should be an absolute pivotal point for any organizations at an international level. We need different ways of telling the ocean stories. We've seen from my colleagues graphs and various different representations, but as an ethnographer, I collect stories from fishers and fishing communities and producers, and I try to relate them in different ways. So all of these forms of telling the stories are absolutely crucial if we are to get the story out and to break the ignorance that continues to afflict the health of the oceans and all the people, which is to say all of us who rely on it. Now, I'm going to finish by saying spasiba. I hope that is correct. Thank you for listening. And I also hope for collaboration between and among APEC universities. I was fascinated to see that the Far Eastern University is directly above Sydney. It takes 20 hours to fly there, but it is directly above us. And I'm hoping that all of these channels can produce more collaborative and engaged research. So thank you very much.
Thank you very much for your presentation. Dear participants, we just finished the list of the presentations, and so thank you very much for that comprehensive reports you've done for the topic of our session. Unfortunately, we gone out of time set for this session, set by the organizers. So fortunately, we have facilitated to finish all the list of the presenters, but now we need to conclude. So that was my pleasure to assist you moderating the flow of the session. And now I given the floor back to another moderator of the session, Dr. Vinnikov.
Dear speakers, thank you so much for your great talks, and I think that together we are able to make a very great contribution to the UN Decade of Global Ocean and Sustainable Development. So I think we will make some layer these acknowledgements of this talk, and maybe we can also communicate after to bring attention to different aspects of what we talked today, or what we didn't talk today, but what is still important, and make some collaboration in promoting these directions and between APEC universities. I think this is very important. Thank you so much again for your participation, and keep in touch. Thank you.